Hello everyone, this is Ashwath here. So in this video, I'm just gonna walk through my prototype. So first, let's take a look at the project structure. So the A folder is the backend. So it has everything that is on the backend, and the window.py is the front end. So it is what it has the code for the GTK text editor that I made. So starting off, I'm just using a pane, so just to get the sidebar kind of thing. So it's going to give us a flexible resizable sidebar, and I have few variables to store the metadata and for processing other events. So let's take a look at what we are doing here. So starting off, we are creating the text editor. So this is basic text editor made using the text view, and I'm connecting an event, so text insert event to the text editor. So basically to monitor when the user types text. So and about the sidebar, it's gonna have the label and a spinner. So this spinner is used to indicate when the grammar correction process is going on. So just so the user is aware of that something is happening on the back end. So yeah, it's gonna act as an indicator. And I have these three buttons. So this is this is going to store the level of the user. So basically, let's say the user is a kid, so they might set the level to low, and if the user is an adult, the they set their level to high. So this is for the level of inputs that they get from the model. So if the user is an adult, they're gonna get all the responses out of the model, and the responses would be somewhat high in level. So it's gonna have technical terms in that. Whereas for a kid, we don't want to put in a lot of technical words into the responses, so we are going to simplify it. So that is where the levels come into play. So you can see all the three buttons that we have in here. So as of my prototype, I'm using this button, but if I have to implement this in Sugar, then I would just take in the inputs from the user metadata. So basically, when the user first comes into Sugar, they choose their age group. So based on that information, I would be giving out the responses which are suitable for that age group. And that is basically it about the text editor and sidebar. And this is a custom tag that we create for highlighting the mistakes in the editor. So we can see we have these highlights happening on the text. So that is about that. So now let's take a look at the events that are attached to the buffer. So we get the on text event. So on text inserted. So in this event, I'm getting the time, the last time when the user types in, and so I'm adding an timeout event here. So basically every second I'm calling a function to check the time interval between now and the last time when the user has typed. So this function gets called, and it checks for it calculates the interval, and if the interval is more than 5 seconds, then we call the grammar check function. So this function is going to get the text in the buffer, and it's going to spin up a thread. So this thread is going to make the API call to the backend. So why thread? Because while the response is going on, I mean the request is going on, it takes a lot of time, and it stops all the processes that are happening on the GTK. So we need to run the GTK process and the request parallelly. So I'm making the request, I'm passing on the text, and I'm passing down the level of the user, and I just have few error handling, and I'm calling the function to handle the response. So this glib idle add function is going to act like a thread. So basically it run the processes that we pass into the function when the CPU is idle. So it doesn't interfere with the GTK processes, so everything runs parallelly. And here we can see I have this spinner that I started before sending the request, and I am stopping that spinner. So this will indicate the user that the process is going on the back end. So this is where I handle the responses. So I clear all the previous stuff. So basically I remove all the suggestions out of the box. I remove all the highlights that happen on the text editor, and I clear out all the metadata that I received from the previous response. And now I'm going to create a new box to contain all the suggestions, and I'm going to iterate through the suggestions that we received, and I'm going to omit the suggestions which have the importance of none. So basically it means that the sentence doesn't require a grammatical correction because it is already correct. Now I'm going to find that piece of text in the text buffer, and you can see I'm using something called mark. So initially I stored the iterators in the suggestions. So because using the iterators, we can directly access the text that is in the text buffer. We don't need to search for it again. But unfortunately, iterators are dropped when the text is edited. So it is something which cannot be persisted. So for this scenario, GTK suggests us to use mark. So mark will track the piece of text even when the text is being edited. So I'm adding a mark at the front of the text, and this is going to stay on the left side of the iterator even if the text grows. So if the text grows on the left side, it's gonna still stay on the left side, and if the text grows on the right, then it would be in the same position. And I'm also adding an end mark. So the end mark would grow on the right side. So when the text grows, it stays on the right end of the text. And I am applying highlight, the custom highlight that we made for that piece of mark, and I am creating a widget for each suggestion. So let's see about that. and I'm just storing all the data in the suggestions, so it can be used later. So this is the clear preview result that we see. So I just remove all the tags and I remove all the children in the scrolling window, basically the sidebar. And this is the function which creates the widget for the individual suggestion. So I'm having a label, and the label is going to contain each sentence and its corrected form and the reason why the change is required. And I just have all the styling stuff, and I add a event box to that piece of widget. So basically the event box is used to get the on click events. So here is the highlight text. So this is gonna get the text in the particular mark, and it's going to highlight the text. And this is the replace text function. So on clicking the suggestions, this is going to do that autocomplete part. So it detects the event, it gets the suggestion out of the suggestions dictionary, and it's going to find the text in that text buffer. It's going to delete that piece of text, and it's going to insert the corrected part in the same place. So after that we remove the suggestion from the sidebar and destroy that widget, and we clear out the highlight on that particular mark. So, and finally we have the load CSS function. This is going to load the CSS that we have for the sidebar. And that's it about the front end. Let's now take a look at the back end. So the requirements for the backend are LangChain, Fast API, and Olama. The tech stack, I just went with the tech stack that has been used in the previous GSoC projects, which involved AI. So let's go to the main.py. So it's gonna have the basic imports. It's gonna load the env. So about the env, so this is the Langsmith environment variables. So this is basically used to trace all the functions that is going on in the backend. So the main.py, we have two routes. So the first one is just to get the grammar corrections. So this would pass the text into the model, and it will get back the corrected text. And let's take a look at this second route. So the second route is same as the first route, but it has an additional step involved. So after getting back the response from the grammar correcting part, we now simplify the responses according to the user level. So let's see about that in detail. And for the type validation, I'm using the Pydantic library to declare all the types. So in Fast API, if we make use of the types from the Pydantic library, then it would automatically do type checking whenever the data is passed into the function and when it comes out. So it's gonna take care of the type validation. And let's take a look at the model. So I just have the basic imports, and the first template is for the grammar correction part. So it's gonna give out a JSON like this, and this is something called output fixing parser. So basically, when we are expecting JSON out of model, it might make some syntax errors. So we are gonna use something called output fixing parser, which would get in the incorrect JSON and corrects it. And finally we have this prompt template, which is going to be used to simplify the response that we get. So this is the model class. So I'm using the Olama client through the LangChain Olama, and I'm loading the model. So let's take a look. So first function is invoke function. So this is going to call the model using the grammar checking template, and it's gonna give us back the response. And second is the batch function. So this function is going to get all the response. It's going to store all the reasons, and I'm creating template for each of the reasons that I get out of the model. So and I pass it to the model. But unlike the first function, which runs just a single time, this runs asynchronously, and it spins up multiple instances of the model at the same time. So this function a batch is asynchronous batch. So basically it spins up multiple instances of the model and runs all the query asynchronously. And I'm just aggregating all the results that I get from the both of the models, and just I'm passing it back. So that's it about the backend. You can see here, so these are the text that we pass, and this is what that is coming out of the model. So it's gonna give us the corrected version and the importance of it, and it's gonna give us the reason. So first you can see the grammar correction part is going on. So we pass down the template, we pass down the sentences, and it's going to give us the JSON. And the second part is the result simplification part. So you can see first we create all the templates. So these three part is ran sequentially, and after that the model part. So these the models they are running asynchronously at the same time. So you can see in total we took around 155 seconds. So the first part took 87 seconds, and the second part took 67 seconds, the maximum out of all three execution. So we pass down the prompt for simplification, we pass down the sentence, and we get the simplified sentence. So we can see the waterfall graph here. So we can see these three things are executing simultaneously, and this is the first part and this is the second part. So that's it about the prototype. So this is how it looks. So if the text doesn't need any corrections, then it does not highlight that. If it needs correction, it highlights that, and it's going to display it in here. And based on the importance of that correction, it's going to give us whether it's going to show us red, yellow, green. So if the correction is really needed, then it's going to put red color, and if the response could be little better, or suggesting some other words since to make the text better, it's going to give out the green color. So that's it about the prototype.